before I teach standard deviation, okay, the meaning of standard deviation, let me give you two sets of data. Okay, let me give you two sets of data, and let's see, based on the mean and the standard deviation. Okay, based on the mean and median, can you tell me whether, okay, the set of data that I have is skewed left or skewed right? If you want to know what is skewed left or skewed right, what you can do is you can go to page 154, distribution. Huh? Okay, distribution. Okay, I know this will appear in your chapter 9 again, chapter 8 again. Okay, but now I want to give you two. Set A, the expected value, which is the mean, is 30. Median is equal to 25. Okay, set B. EY is equal to the mean. So set B, the variable is called Y. The mean is okay, I can even give you the mode. Okay, this one, the mean is the median is equal to 30. And the mode is equal to 32, for example. Okay, now you tell me. Okay, if you have the mean which is more than the median, what can you say? Okay, both the number of data, both is, okay, 20. Both have 20 data. So what do you think? How do you imagine? If people give you the situation like that, how can you imagine how is the data look like? I know 10 of the data is more than 25. I have 10 of the data which is less than 25 for set A. Am I right? Because 25 is the median. Okay? But is 25 one of the data? May not. It may not. No one knows. Okay? And for set B, I know that 10 of the data is more than 30. 10 of the data is less than 30. But the mean of set A is greater than the median. The mean of set B is less than the median. So what can you imagine? What pull the mean of set A up? What pull the mean of set A up more than the median, more than the middle number? Hello? You cannot imagine? mean so high? Can I say that the 10 data, which is more than 25, is way above 25 compared to those 10 data which are less than 25. They are quite near 25. That's why they pull the mean up. Can I say like that? Can I say like that? Isn't it logic? So this type of distribution, we call it skewed right. Because you have extreme positive value. Extreme value which is more than the median. Way high up. Like for example, in our everyday life, you can talk about like monthly pay. How many people can have monthly pay which is 30,000-40,000 a month? How many? There are very few, correct? But that 30,000, 40,000 a month, they can pull the whole mean up. That's why every time when you see in this world, correct? In this world, if you see the country average income, the mean income for the country, correct? They really want to see the mean income of the normal people like you and me. You may not be one of them, okay, because your parents may be filthy rich, okay, like us, correct? Our income may not. Have you ever go and check what is the mean income for Malaysian? Household income? Go and check. You can get the data from that. So they include all the very, very filthy rich people. There are only a few, but they pull the whole mean up. You see or not? So this is called skewed right. If the mean is more than the median, the distribution is like that. You have very few but extreme value, which is more than the median. Way, way, way above median. Right? If I'm talking about the students' mark in the SAT, on the SAT, correct? That means if I'm talking about class A and class B, correct, for about our SAT, am I right? So it shows that for this class, correct? Okay, those get around 25 or more. I have very few students, very few, which is extremely good. Are you clear? So this is called positively skewed. You go to the right. Go to the right always is positive. So we call it right skew. Okay? Can or not? So it's judged by the mean and the median. You have very big extreme mean that pull the very extreme big value that pull the whole mean up. Okay, the other one I don't have to explain it. You should be able to understand. Am I right? It's the other way around. This one will be skewed. So sometimes in statistics, correct, if we want to have the true picture, if we want to have the true picture of the whole thing, correct? If we want to have the true picture of the whole thing, am I right? What we need to do is we have to omit the extreme value. We usually omit the extreme value. That's why we also count first quartile and third quartile. So that is to omit the extreme value. Are you clear? Okay. So that is how you use mean and median to judge. If people didn't give you the data, you based on the mean and the median, you can interpret. Clear? Okay. So now I want to talk about standard deviation. Okay. So you please go to page. So measure of center. Okay. Then you can see in page 162. Page 162, skew right, skew left. And you also can have double. So please read. You don't read, you won't be able to learn. Okay, now let's go to part C. Part C, variance and standard deviation. Okay, if you use the standard deviation formula, allow me to write down the formula first before I explain. So I'm not going to write down the variance formula. I'm going to write down the standard deviation formula. Okay, this is the standard deviation for population. And this is the standard deviation for sample. So the difference is, the difference of the formula is, I don't know why statistician they put like that, they have a reason for it. I try to find the reason, I can't get the reason because I'm not the formula developer, okay? So I won't be able to tell you. I try to find the reason, I don't know why. Okay, and this one is, the formula is like that. And here they put n-1, the only difference. Okay, maybe it's because the sample is part of the population. So they assume the standard deviation of the sample is bigger. That's why they put the formula as n-1. Because when you divide by a smaller number, you will be bigger. Am I right? Logic? Okay, good. Okay, now let me give you the definition of standard deviation. Okay. Standard deviation is the average difference, or we should say mean, average difference of each data from the mean. So that is called standard deviation. Okay, average difference of each data from the mean. That's why when we, in maths, when we say difference, we must take the big minus the small. Am I right? That's called difference. So we know pretty well that some of the data may be more than the mean, some of the data may be less than the mean. So how to overcome that? There are two ways to overcome that. If you take the data minus the mean, if you square it, then you will get it of the negative sign. Am I right? If the data is smaller than the mean, I got negative sign, but I square it, it will become positive. Am I right? So that's why the formula there, they square it. So actually variance is no meaning. Variance is just without the square root. After you square it, you want to know the actual spread, correct? You have to take the square root, correct? You get back the actual size. Am I right? So actually variance is just a way for us to get it off the negative side. If we just take the difference, data minus mean, some is negative value, some is positive value, you add up, at the end you get what? 0. If you study physics, we don't use this formula. What do we use? You study physics, we use like that. When you want to count precision in physics, you study year 11, year 10 physics, first chapter itself. When you talk about unit of measurement, What is the difference between consistency, accuracy, and another one? What is it? Sensitivity. These three words you know not in physics. Okay, never mind. I'm not teaching physics anyhow. So you use modulus. So that way also, but it's harder. Right? So now you understand what is the meaning of standard deviation. You talk about the average difference of the data from the mean. So you are talking about the spread of the data from where? From the mean. That is the meaning of standard deviation. Please write it down by yourself. I'm not going to write. So if the standard deviation is big, that means the spread is big. From where? From the mean. The key is here, from the mean. Are you okay? So do you know the meaning of standard deviation now? So variance actually is just without the square root. Why? Why you want to square it? You know the reason. Right? So usually we won't ask you to find the variance, but SPM textbook, right? They always ask you to find the variance. To me, I will never ask my student to find the variance. I will ask my student to find the standard deviation. So in another word, I also can say that standard deviation is the spread of the data from the mean. So that is another concept. So how much is spread from the mean? If the standard deviation is big, that means the spread from the mean is big. So I will know. So every time when we count your mark last time, okay, nowadays we don't count because you go by grade. Last time we have the mark, all right, I will count the mean. Excel can straight away count the mean, the standard deviation, the median, everything there. So if I have a class which have a very high standard deviation from the mean, standard deviation. So we now, whenever I say standard deviation, I mean the spread from where? Mr. Sebastian. Continue my sentence. Yes? Hey, median max. If I say standard deviation, that means I'm talking about the spread of the data from the mean. That's why you minus the mean. Are you clear? There is another formula. You still remember there's another formula in high school? Do you have this formula? This also can be used. And this is easier to use compared to the one on the left. If it's a group data, then you will use the midpoint. Right? Do you still remember? If it's a group data, the formula will go like that. Hello? You got this? So please, all this, please recall. Will the formula be asked? No one knows. Okay? So this is the meaning of a standard deviation. How much the data on average, the data spread from the mean. That is the meaning of standard deviation. And how can I count the standard deviation? Okay, there are two ways. One using the formula, the other one use your GC. Do you know how to use your GC to count the standard deviation? Yes or no? Very simple. You go, you key in the data, click from there, go to stack again. You once stack, everything is up. Am I right? Okay, please. Okay, everyone, go to page 175. Do question 5. Page 175, question 5. Exercise 6C.1. Everyone, please. Page 175, question 5. Exercise 6C.1. Take out your calculator and key in. I can give you another 5 minutes only. I have to go to the other class. They are having their SAT one. Okay, those online, consistency means you have to look at the standard deviation. The lower the spread, the higher the consistency. Please record that down. Okay, so I expect you to try to do exercise until 6C.1. Okay, so you cannot say, I don't know how to use the formula. As long as you can use the calculator, you know how to read this. Okay, and you have to be very careful. This is from the sample. Okay, the rest I will leave it to you. So the purpose of us calculating the standard deviation is to know the spread of the data from the mean and to show the consistency of it. So if we are doing science experiment, okay, just let you have some idea. If you are doing science, any science student here? Oh no, no science student, no one taking science. Physics. Okay, if physics, correct, we only count consistency if we are talking about repeated measurement. Repeated measurement, so that we want to get the highest accuracy. Repeated measurement, like for example, you want to measure the diameter of a wire, because at the different place it will be different. That's why you measure a few, you find the mean, then after that you find the standard deviation. Actually, you have the right to use your graphic calculator to do so. Do you know in your exam for physics or for chemistry, correct, you can bring in your graphic calculator as well. That can help you to plot the graph as well. Do you know that? You know? Don't know. If I got correct, physics sure got ask you to plot the graph. Am I right? So you can just key into your graphic calculator and put stack plot, zoom in, stack plot, then the graphic calculator will plot it nicely for you. You transfer onto the graph paper. That is how you make full use of your graphic calculator. That's why Maths is more important. Maths can help you in other subjects. Okay, so can I end the class? Okay, so please try to do until exercise 6C.1. Yeah, so actually I have done the whole chapter. Do you know that? So this whole chapter is I'm trying to get you to know the meaning and how to interpret mean, median, mode, and standard deviation. Are you clear? Okay, thank you, class. I have to run.